So, thinking about this disparity between how many languages there are in the world and which are the largest existing resources in terms of models, data, or deployed systems. So, Meta's been very active there. They're probably preeminent right now. The No Language Left Behind project. So they have open models which support 200 languages. Google Translate has a bunch of languages, although that's proprietary. Datasets, there's the Opus project with lots more languages. All of these have different caveats. So Google Translate, obviously this is a proprietary model, so you can't fine tune it or add languages or things like that. There's various restrictions. Opus, even in LLB, things based on web scrape data have all these quality issues, right? So when we looked into Opus data for Ugandan languages, most of the time it was incorrectly identified as that language. So most times the text, where you have text pairs, often it's not actually the language it says it is, because there's been some issue identifying the language. I'm sure this is much better for like larger languages with more digital resources. It's easier to, the more resources there are, the easier it is to find even more, because you can train the language ID and so on. But it's very difficult. We've not been able to use that to train with for the languages we use. Then speech recognition, again, there's Meta. MMS is pretty cool. It's a useful model. More than 1,000 languages. There are, again, caveats. So most of these have been trained with a single speaker. So that's like people reading out the Bible, and then you take that one voice and train a model. And so it generalizes like somewhat to other voices. But it needs, it's not really all that ready to use out of the box for a sort of practical deployments. It takes a bit of fine tuning. Then common voices, amazing, but covers a pretty small proportion of the world's languages. So the median language in the world has a few tens of thousands of speakers. So what realistic plan is there for getting everyone able to communicate? One option is to wait 100 years. Linguists predict that by the end of the century, 90% of the currently spoken languages will be extinct. Tragically, the loss of the culture, the traditions, the perspective, which is enshrined in these languages, as their languages are very precious, and they are dying. I don't think we want to do that. Just sort of wait for them to disappear. We want to get the models working now, and I think this is more possible than is commonly thought. So here's the perspective. Our team is based in Uganda, and Uganda makes a pretty good case study, I think. So it's got the 10th highest linguistic diversity index worldwide, so about 45 languages. Why about? Like, why can't I say exactly how many languages? We'll come to that later. Here's my claim. If we can demonstrate a process for like fully supporting Ugandan languages, like being able to do translation, speech recognition, speech generation for everyone in Uganda, then I think we've got a pretty good case for like a model which could be replicated, that could do the whole continent or the rest of the world. Okay, so how does that work, and what doesn't work? So I believe that the kind of centralized model will not achieve this. So the kind of build it in California, or build it in some centralized place somewhere, like harvest the data from the internet or by paying contractors or something, and like train the models in one place. So I don't think that's going to work. It's quite impressive what the large companies do, but it's it's not going to get to like very good models for thousands of languages. So what does work? Long story short, I think we believe every country in the in the world needs like an NLP or AI team, working on this. Could be volunteers, students, academics, forming these groups which create the data, train the models, get them working on problems of interest. And I think at the moment, to get things working, you need on average about one local NLP enthusiast per like maybe 2 million population on average. I think with maybe 500 to 1,000 people across the continent, that would be enough to do it. And it's it's picking up. I think we're gonna get there. So what we're trying to do in Sunbird with the SALT, our contribution to this through the SALT project, the Sunbird African Language Technology project, is to provide some resources to make that easier, to get people off the ground faster, open source things that people could reuse or adapt for their own languages, in combination with other projects, other open source things, other data sets. That's all interoperable. So the idea is, are there models which can converge faster because they've been trained on other languages from similar language groups, tools for rapidly experimenting, data sets, protocols for collecting data, experiences about how to do that within this context, proofs of concept, templates for the actual deployment, which we'll talk about that later too, is a little bit more difficult than there's training things which get good benchmarks and good metrics, but then actually getting something to work is a whole sort of extra level beyond that. So that's our hope, is that by providing these materials, then that stimulates this process in other countries. It's something people can copy and paste and own elsewhere. All right, and we're kind of getting there. So like here's a list of a mostly comprehensive list of Ugandan languages, and color coded by coverage. So what does coverage mean here? It means we've collected translations for a set of 25,000 sentences, speech recognition, like samples of several people speaking and recording 5,000 of those sentences, and then another 5,000 sentences spoken in a studio environment by a professional voice actor or announcer. And we find that's enough to get things off the ground. Not enough to have very nuanced, like sophisticated models, but like good enough for a bunch of like practical purposes. We'll talk about how good they are and what the limitations are later. But it's like a kind of a starter pack, for each language, which basically gets things working. So yeah, we're kind of making progress. Even with a few people on this, we're gradually ticking off the languages. We hope to keep deepening the ones which are there already and adding on. And the cool thing is, it gets a bit easier each time, both because we get used to the process and how to do the coordination, but also because when we're training the models, many of these languages are related to each other. So you can see the language groups. The languages are very different across language groups. Training a model for a Nilotic language doesn't help a great deal with training a Bantu language, but it helps a bunch with other Nilotic languages. So as you extend to a new language, that gets easier each time because you have something the models already know, like similar patterns, and so it kind of gets easier and easier. Making models for new languages, you go into this expecting that you're going to be doing like model architectures and getting into the details of how the models work. There's a little bit of this, right? I mean, it's not that there's nothing, and there's definitely a lot to be said for experimenting with architectures, adapters and different ways of training and different ways of setting up the data and all of that. But the reality is mainly this is a coordination problem. Like finding the people who contribute data, how's that organized? Is there Like, is there funding for that? How do you like pay people for their time? How do you get consensus on things like spelling, or which words should be representative of the language, or where English loan words should be used? Like, finding the groups of people is often the kind of key. And then meetings. Down here we can see activities by our collaborators at Maseno University and Ken Corpus, and you have to have all these meetings, like deciding on spelling, and so forth. Then keeping track of the data is really tricky, because you have to have multiple layers of validation. You do your first pass, it's got a bunch of errors. Gradually you reduce them. You've got to keep track of the versions and all of that. So it's a big coordination problem, essentially. Mostly it's like 90% coordination, 10% machine learning technology. So let's get into that. Feel free, anyone, stop me at any time. Put your hand up, or type a message in chat. I would be delighted to answer any questions. But we can wait till the end too. That's also fine. So let's go into dataset creation, which is basically the heart of the matter. I'll talk about dataset creation. After this, I'll talk about how we iterate on our models, like identify the weaknesses and try to improve, and then finally on deployment and the practical side and some things we've found out about there. So where we started was with translation data, and the core translation data set that we have, Sunbird/Salt on Hugging Face. So it's 25,000 sentences. We started with English seed sentences, and we had a process for coming up with these sentences where we'd look at like newspaper headlines and get inspiration for that, and write bits of dialogue or factual statements. A lot of this happened in the Cohere AI lab, where they have quite some experience of this, and then translate every sentence across the other languages. So this is one great thing about having all the sentences in every language, is you can train like embeddings, or you can train translations to translate in any direction, between. So you don't need to use English as a pivot language. You can go directly from Acholi to Lugbara, or any other combination. So that's the translation data. Sometimes we have to accommodate the way to obtain the data which comes easiest to people. So an interesting finding we had here is that if you want to get authoritative language usage, we'd be looking at elders, people who are older, who have the experience of the language and the kind of authority, but may have more difficulty with digital tools. And so this is Acholi data, where we have people who prefer to like do handwritten validation, write their corrections and then kind of send that physically onto us, where we would scan it and do the data entry. So we kind of need some flexibility on how we do that. Then speech recognition data collection, we would so we do this with WhatsApp. So recruit people to help out with this, and people sign up to a WhatsApp channel. They receive a prompt with some text, read out that text and send it back to us as a voice note. And there's so we'd aim for 5,000 sentences read out per language, ideally by like a few tens of individuals of different genders and ages. Then the final part of the set, the kind of package for each language, is studio data. So we need text-to-speech data. So rather than having many individuals reading the sentences, for each language we have a single individual, and they record their voices in like a studio setting, and without background noise, and professionally, the intonation, and And that gives us the kit. So it looks like this. So we have these set of sentences, 25,000 sentences, and for 5,000 of them we have this completely filled out. I was going to put examples, audio examples for all the languages, but I kind of timed out while I was preparing this talk. Okay, so here is like one sentence. It's translated across all the languages, and then we have the multi-speaker. I think that's. Okay, so we have different individuals like reading out those sentences in kind of real world. This is just speaking into WhatsApp, so you can hear background noise and people speak in different ways and all of that. And then we have the studio speech reading out the same sentence. So that very clear, like professional intonation, and we have that for all of the languages. So if I'd had a little more time, I would have added all the examples for the different languages. What's cool about this is you can set up training and evaluation data for all sorts of tasks. We can train we mainly train like translation and speech recognition right now, but you could have models which took the audio from one language and then took the audio from one language and then they've got to translate that to the text in a different language. Or it could be the audio in one language goes to the speech, like the professional sounding speech of a different language, like speech to speech translation. So there's various kind of configurations which are possible with this data. And then there's the general possibility to train with embeddings and all of that, like any speech or any text, if it's all indexed by the same sentence ID, then it's all kind of got the same, it should all be have the same position in the embedding space. Like all of these represent the same kind of concept. Somewhere in concept space, they're all kind of at the same point. Okay, so having collected the data, then we've got to train stuff. So right now we're using Meta's NLB, Language Left Behind. We use their 1.3 billion parameter model as our base for fine-tuning. So it's got support for two of the languages we're interested in already, Luganda and Swahili. Not super strong support. We find the model is not out of the box ready for practical translation tasks, but it fine-tunes quite quickly. It's been trained on like web scrape data with various quality issues and so forth, and with lots of other languages. So yeah, the value there is in the sort of pre-training and you can fine-tune and fit quickly. Okay, I don't have. I was going to put blue scores in there, oh man, I have to look that up. Okay, so the basically pre-trained, we have blue scores like sort of 10 to 15, and then they go up to sort of 30s, 30 to 40 range. It gets way better after fine-tuning. We have to do some tweaks in the code. So NLB 200, it's the model which is available through Hugging Face can't by default be trained multilingually. It's a multilingual model, but the training recipes only allow like a single target language. So we have to do a bit of modification to be able to do this like full kind of any to any direction training. And what usually happens, so we've been through like 3 different translation-based models, and each time we get a better pre-trained candidate which appears publicly, then we update the SALT utils module so that we can wrap that and be able to just switch to whatever's the best thing currently. So speech recognition, we're kind of we look at both Meta's massively multilingual speech project and Whisper. MMS, both of these have pros and cons. So MMS it's a CTC model, so it's unpunctuated, it's lowercase, and the outputs of that are often not directly all that usable. So we need to train a second model which takes unpunctuated lowercase text in the local languages and then puts back the punctuation. So so that's a, a little inconvenient that you have to pass everything through a second model, but it converges really quickly. You can train quickly, and we get good word error rates and character error rates from this. Whisper, that works really well for English out of the box, and it takes very little fine tuning before it really gets like the Ugandan English accent. But because of this, it is pretty English centric, and it takes a long time to train for the salt languages. So often we need like to train on a. I think our last training run was like an A100, like an 80 GB GPU for like 20 hours or so. And so it's a lot longer to converge. Okay, question here in the chat. In the machine translation, you mentioned speech to speech or ASR machine translation. Thanks for the question. So we do neither of those at the moment. We do translation, which is text-to-text translation. So that's one model that we train. And we train speech recognition, like transcription, just the audio, and we recognize the text in that language. So if we're doing speech-to-speech or ASR machine translation or like speech translation, then we cascade those models together. First recognize the words, then pass them through a text translation model, and then we can create the speech on the way out if we want to do full speech-to-speech. So it's a series of separate models that we plug together. And the accuracy is, so far that's the highest accuracy we've seen. We've not had any attempt we've had to try to do this end to end has been lower in accuracy. I hope that answers the question. Yes, we're looking at both of these. I think we're tending towards Whisper at the moment. So currently we've got MMS in deployment, but I think Whisper is looking more encouraging right now, if we can figure out how to kind of boost its multilinguality. One thing we spent a while doing in terms of training is getting the training utilities and having examples to train, so that we don't need very much code in the training scripts or the training notebooks, because we get so many bugs. It's so easy to get bugs while training. For example, anything to do with speech, it's really easy to get the sampling rate wrong or to have some mismatch somewhere. And a couple of times we've been set back a few weeks, like doing a round of training and then realizing there was something wrong, and we have to go back and do it again. So what we try to do with the Salt code base is have everything in a config file, how the data set is set up, which separate data sets it's composed of, which pre-processing operations are done, and then all of these are operations which are covered by unit tests. So we have some assurances that the code does what we think it's doing, and then the actual notebook for training is pretty lightweight. There's not much code there or opportunity for things to go wrong. And then this is quite flexible for setting up new versions of the task. So recall the data structure that we have, where for each sentence we've got the text form and the speech form, and we've got speech as multi-speaker or studio. And so in this config, we could just change like the source or the target type from text to speech, and then instead of like a text translation data, you get a speech translation data set, and all those different configurations. So this is a template, and the idea is to make it easy for other people to use this to do their experiments. So for example, at Maseno University, we helped one of the students was working on Kenyan Sign Language, and we got that up and running fairly quickly. Yeah, so question on chat. Alan, for the text-to-speech SALT dataset, can you make it available with the actual audio files, not the audio representation? So right now we've got it's on Hugging Face, and you get the like array, like the wave array. So you could recreate the files, right? Like if you wanted, you could take the you could take the array and then like save that as a WAV or an MP3. Is there something I'm missing? Maybe Ellen, you could expand on that question. Is there an advantage to having the files rather than the array of the raw data? Not sure if Alan has a Purity. Does everyone have ability to unmute and ask questions?
Yes, we can. Alan.
Okay, deep audio cleaning. Well, you could. I mean, if you want WAV or MP3, you could just create them right from the. So you could have a loop which went through the audio arrays, and then you could just write that to WAV or MP3. So you could construct those files and then use them. You know, I would think in a Colab CPU instance that would you know probably be possible in an hour or two. I would guess. Anyway, the data's there, so I guess you know the format could be people could convert that to whatever they find useful. Cool. Okay. So a few metrics. Speech recognition. You know. So what do we get with this kind of starter pack per language of like the 5,000 sentences? So so we see like English. So we get this 1% word error rate, which is would be amazing if that actually was the case in real life. We find when you come to deployment, the error rates are in practice a bit higher, but on our test set we get 1% word error rate, which is extremely good. This is on Whisper, by the way. I don't have the MMS metrics here. You know, Whisper is very English focused, so like you can fine tune to any English accent and it really gets it. And then for the other languages, so like Uganda, we see this kind of 10% word error rate, which is pretty good. And this is producing like formatted, punctuated text. So this is something we're quite actively trying to improve just now. And then for the other languages, you know, sort of 20s, 30s. So like, so not flawless, like there's certainly noticeable errors in the output, but like by and large kind of getting it, you know, like these are good enough numbers that it's useful for various practical purposes. Oh, and I should say, yeah, these for both of the models, Whisper and MMS, they're fairly similar in terms of word error rate. MMS supports all of the languages we're interested in already, but with error rates that are kind of start off around like 70 or 80% and then come down quite a bunch with fine tuning. Yeah, so just to kind of illustrate how it helps to have like good quality fine tuning data. Okay, so after the initial training, then what we try to do next is understand the shortcomings, like where are the models going wrong, either for translation or for speech recognition. And so what happens here is we try to, you know, get out there, get on the ground and ask people. So you know, here's Solomon on our team I believe this is in Yumbe, and he's in Uganda, in like northeast Uganda, looking at northwest Uganda, looking at Lugbara, and kind of, you know, taking people through the system, and they try it out and give their feedback. And this is really interesting. You know, for example, that we found we hadn't realized that there's three versions of Lugbara. So there's like Lugbara Aringa, Lugbara Ayivu, which is what we have been working with, and Lugbara Terego, and you know, so you sort of find a level of detail about how this works, and we get to understand that, okay, maybe we need extra data from those other Lugbara speaking areas so that we can generalize to them. On a side note, I would love to, if we could either get away with get rid of language codes altogether, or supplement them with longitude and latitude. I think that language areas drawn on a map are pretty artificial, and in practice languages tend to morph as you move around. Like some words maybe become more common uh, uh, um, as you move from one kind of language area into another. And I would love to see a model which would do something like express this concept as it would be spoken at this longitude latitude location, because there are these limitations with language codes. Yeah, so we get to find out all the types of things that don't work very well. So for example, in translation, we deal fairly well, we think, with like factual statements, which is a lot of how the salt data set is set up. But if it's like informality, we have endless problems with being able to translate the word hello. Our models would really just not know what to do with that. And often it's these kind of simple greetings and things where it goes wrong, and then we realize, okay, we need extra training data of that, so we've got to collect data on the greetings. So a couple of examples here in Uganda, like figures of speech, okulio bulamu, it's like literally kind of eating life, but the sense which someone is communicating is it's like kind of having a good time or something like that. Whereas the model will try to give this literal interpretation. Usuziotia, I suppose that's not bad, but it's like kind of good morning or how did you sleep? Then paka last up to the last. The model's got no idea what to do with that. So we need extra training data. We need more examples of that kind of informal or idiomatic usage. And we even thought at one point, should we have translation models which do 2 levels of translation? Give the literal translation, but then also some translator's notes. This is a proverb, or this expression. You interpret it this way. As more of an LLM type approach, perhaps. Other things that we get to find out. So looking at translation, you start off collecting sentences for like language 1 and sentences for language 2, and you think, well, we could train in both directions, right? We could train a model which goes from language 1 to language 2, and we could use that same pair to train a model which can go from language 2 to language 1, but not the case. For example, many of the languages we're dealing with here have gender-neutral pronouns. So if someone's saying like that person went to Kampala, Agenda Kampala, like there's no specification of if that's male or female. It's just like the person went to Kampala. If you put this into Google Translate or NLLB, then it will invent a gender. So yeah, and that's going to be related to statistical bias. So if it's taking the children, it's going to invent that it's a female, and so on. So we have to do that correction. We can't just automatically train in both directions. And if we're training from a local language to English, then depending on the language, we may have to adjust the pronouns. So what we do is use they, like as in, in this example, they take care of the children, like the singular they, that person went home, that person goes home, and they take care of the children. And this isn't ideal because they could be confused with the group. It sounds like the group, are looking after the children. So should it be he stroke she takes care of the children? But then the sentence gets a bit difficult to read if you have many he stroke she's. So yeah, still working on this. But either way, I think this is better than kind of inventing like a gender, because that can be pretty confusing. For it can take away from the objective of trying to give people an informative translation. But the point is, when the team itself speaks the languages where we're training the models for, then it's possible to kind of notice these things and fix them, which is very difficult to do from a centralized team, where it's kind of globally coordinated from somewhere else, and the people training the models don't actually speak the languages, and these kind of things slip through the cracks, and I think that's why you see these issues here with Google Translate. So next thing we've been doing, which is a great source of finding out the current problems, is break the system. So we ask people to find examples that our systems can't handle. Either people help us out online from seeing our social media, or we convene people or have workshops and that kind of thing. And the idea is we ask people, like, can you go to our systems online and try to find examples where it doesn't work? Mainly we've done this for translation so far. So we have some pointers here that, like, nuances or greetings or complex sentences might be difficult, and that's super useful to find out. So a couple of examples here. So what we see here is what the source language is and the target language. Someone gives this input. This was the output that our system gave, and this is what the correct translation should be. So so you get some more like kind of complex sentence structures and things like that, and people give the correction. So we need to translate it. We need to validate these, and it's got to go back to the language experts who kind of give us the correct ones. Like I love this one here where someone's like, I don't know, but that ain't it. Which is still really useful, right? Because we can say, okay, well, that's a bad translation, so let's take it back to this is like the most informative possible type of training data, where it's an example that our current model gets wrong. So this is going to have big gradients, to correct the model when we put the fixed one. This will be a like surprising correction to the model, and it will help it to do better. All right, so let me wrap up with some comments on the practical deployment, which is a whole extra, there's kind of training in this mode of improving the metrics and all of that, but getting it out there is a whole other thing. So we have various ways that we deploy this right now. We have an API people can sign up for. There's a web interface with translate and speech. We've been experimenting with WhatsApp, like a WhatsApp channel, since that's so natural to many people in the region, in this context. Lots of people are really used to sending chat or voice notes and having them having that kind of interaction. So we think that could be a cool way to do translate. It's a bit difficult on WhatsApp because you can't, obviously it's not like a user interface. You have to just take you have to take a natural language conversation and try to translate. And then we work with organizational and custom deployments. And there's all the models available. Our repositories are like a little bit messy. If you look on our Hugging Face, it's all there, but it's a little chaotic right now. So drop me an email if anyone wants to kind of get pointers to code or models and that kind of thing. So we do work with a couple of organizations on deployments, and this again really helps us to understand, are the models useful? Are they useful for specific purposes, or what needs to be done to make them better? So a couple of examples. Track FM is an organization that does radio polls, and they have lots of people send in like SMS. They'll have a poll online. What do you think about this question on land rights or something? And text 1 if your answer is this, or 2 if your answer is this. And we're trying to do voice voting, where people could just call in a free phone number and say what they want to vote for and what their opinion is. But they have tens of thousands of people contributing a week, so it's going to be really interesting to see if we can bring in like voice voting. SEMA Uganda is an organization that does like public feedback on public services. So outside hospitals and police stations, they have these buttons where it's like, press the happy face if you've been happy with your service, or the sad face if you weren't. And we've been looking at making that voice powered, so people can say like what they were happy with or what they were unhappy with, and then that feedback can go back to the organization or the line ministry. It can kind of be written up as a report about what's going right or what's going wrong. And then a couple of others. So like the DFCU, local bank, on if this can help for like customer services in their call center. Amara Hub, is an organization in the north of Uganda that deals with like kind of community advice for young girls and women, and looking at how those messages could be translated. Back up Uganda, again in the north of Uganda, they do these podcasts, and we're looking at transcribing and translating those, and a couple of others. All right, I'm going to wrap up there just in case there's any more questions. But thanks everyone for listening. It's great to have you all here. Drop me a note if any of this is of interest. We've got various links here to the code and data, and I'm happy to help people give people pointers, and there's some web interfaces there too. I'll stop there. Thanks so much.
Yeah, thank you so much, John. So if anyone has a question, then they're free to ask. But I think we can start with one. Andrew had a message on the chat. I don't know if you saw that.
So I see.
Oh, Alan, not Andrew. Sorry.
Oh yeah, I think we dealt with that. That's the one about the audio files. Oh, what's the experience of training from scratch? Ah, great. Sorry, I missed that one. Yeah. Yeah, great question. I don't have the. Yeah, I don't recall. I think for like not very positive overall. I don't have the kind of numbers with me, but I think what we get from pre-trained speech recognition models is the fact that like the human vocal apparatus is basically the same around the world, and there's you know, so you need a model which already has some representation of like the basic sort of, you know, sounds that we can make when we speak, and then there's a bit less training to do with the relatively small amounts of data that we have. So I think training a speech recognition model from scratch is pretty tough. And then on translation, I think what we get there, that's more feasible to train from scratch. But what we get, they're pretty good at like the English side of things. So whenever we're translating to or from English, then we get a lot from a pre-trained model. Just knowing that some words are related to each other, or that, you know, certain concepts might be expressed in various different ways. So I think we sort of get the extra boost for English, but not so much for the other languages. You know, I think for if you're translating directly between local languages, especially if they were within the same group, then probably you could train from scratch with that. But yeah, we're kind of mostly we find we have to start from the pre-trained model. Okay, Andrew, what special techniques do you use in model training? There's a couple of them actually. So I guess we don't have a lot of time to go into all of them, but you know, things like augmentations that we've worked on, like spelling. You know, in the case of text translation, there might be certain common types of spelling translations. Like in Luganda, it's common to like double the letters, or to you know, so you might need text augmentations which reflect that, like character level augmentations. For audio, one thing we're about to do, we have another project at Sunbird doing noise pollution monitoring, and we have these mobile sensors that go around the streets getting like noise from nightclub noises or traffic, all of that, and that's actually really useful data to mix in as background noise into our speech recognition. So we have all this like street noise that we could mix in, so we have the model robust to the type of background noises that really are here. Yeah, and then yeah, there's a couple of things like that, but do get in touch if you're you know, if you're thinking of training something, and I can give you some more specific pointers. Right. And then another question here from Pete. Your approach seems very linguistically informed. Are there trained linguists on your team? That's very flattering. Thank you for that. No, we're definitely making this up as we go along. We do have, so where we have these kind of groups who contribute our data, often that starts with people who are who've done translation work, or they're involved in language in some way. So it might be that they're teachers or writers or something like that. But yeah, we don't. Yeah, none of us are really like linguists as such. We're kind of we're just sort of learning as we go. Right, David, can the model detect which language is spoken? Oh, great question. Yes, I like this. So that's another drawback with MMS. So the different models have different abilities to do this. Whisper has a sort of built-in language detector. MMS, we would need to train a spoken language ID detector as a separate model. So that would be a bit complex. For text, we already have to do this, so we have to train a separate language classifier to first classify the text. And how fast does the model translate audio from local languages to English? Right, so to translate from local language speech to English text, that means running it through two models. So we've got to do the local language speech detection, which runs, so you need a GPU of some sort, but then we can run this kind of 10 to 20 times real time. So a 10-minute audio we might be able to process in like a minute or less, and then the translation is pretty fast. So that might be a few seconds on top of that. So maybe sort of 5 to 10 times the rate that it was spoken in, something like that. And then someone has their, I think.
Yes, Ebenezer, I think he has raised his hand. Yeah, you can go on.
Yeah. Okay, thank you. So I'm from here in Africa, from Ethiopia. So my question is, have you tried to relate more than one dialect together in parallel that have common words? For example, two neighboring tribes may be counted as, they may have different dialect, they may be counted as two different dialects, but they usually have common words, and two individuals from those tribes can actually communicate without any hurdle. And have you tried to use this as an advantage in your training?
Yeah, I think this is an advantage, right? If you've already learned one language, then if you extend into another language where it's very similar, then this gets a lot easier. So an example from, not quite from Ethiopia, but East African. So we have Acholi, which is like a dialect of Luo. So there's Kenyan Luo, and Acholi is like Ugandan Luo. So they're really similar. So that for sure helps. Like if you have a model that understands one, then you can easily generalize that model to the other. The downside is on language identification. So if you have a model which is trying to auto-identify which language you're speaking, then that becomes a bit more difficult. If you have two very similar languages, then the model might get confused, and then sometimes you can downgrade performance because the model, someone's speaking language one, and then the model thinks it's language two, switches into that mode, and then you actually get less accurate translations because of that. But on the whole, it helps if you have things within the same language group. Yeah.
Okay, so I also do have a question. So you mentioned NLB as your NLLB as your base model. But currently there are quite a number of base models that actually has a lot of African languages. Like there's one I came across that had about 500 African languages. So have you tried maybe using these other models, or is NLB like the best so far?
Right. Yeah, so here's NLB 200, so the 1.3 billion parameter is the one that we normally use. Right, so of these 200, about maybe 40 or 50 of them are African languages. So yeah, it's good. We only happen of the languages we work with right now. There's only two of these which are kind of already ready to use. That's Luganda and Swahili. But there's lots of other African languages, so this is for sure pretty useful. The translation performance of this on its own, we find it's not really it's not really ready to use. There's a lot of this is web scrape data, and the blue scores and so on are pretty low just using this model straight away, but it fine tunes really well. So if you're doing Yoruba or Hausa or one of those larger languages which is supported by an LLB, the model is not great to start with, but a little bit of extra data and it really gets a lot better results. I'm sure people on the call have more experience with that. Can you fine tune an ASR model from Zeus, I guess, 400 languages from ESPNet? I don't know what that is. I have to look into that. Thanks. If you have any more information, I'd be happy to hear it.
Yeah, okay. So thank you, John. So it was a good session. And I think we are 4 minutes past the time. Yeah, so thank you everyone for your inputs, and thank you again, John. Hope we'll be in touch more. Yeah.
Yeah, thanks so much. Where can you reach me? Let me put back my contact. So yeah, email's the best. Email's the best thing. Just shoot me an email here. Yeah. All right. Well, thanks so much. Yeah, looking forward to hearing from people and to hear more. All right. Wish you all a nice afternoon or evening. Bye.